Breaking news. At precisely 0:19 a.m. UTC today, observatories across 3 continents reported a set of readings that, quite frankly, should not exist. Data streams coming in from the Atacama Large Millimeter Array in Chile, the European Space Network's deep space antennas in Spain, and NASA's Goldstone facility in California all flagged the same anomaly within seconds of each other. An interstellar object we believed we understood, Comet 3I Atlas, had just done something no comet, no asteroid, no known natural body has ever done before. Today, the impossible just happened. Moments ago, trajectory models that had been stable for weeks collapsed. Velocity plots spiked, then flattened. Thermal readings dropped where they should have risen. And one signal, brief, precise, and deeply unsettling, appeared exactly where nothing should have been at all. This changes everything we thought we knew about this object. If you want more real-time cosmic updates like this, stories unfolding not over centuries but over hours, make sure to hit like, subscribe, and stay with us, because what's happening right now, out there beyond Mars, may be the most important astronomical mystery of our lifetime. Only now, with the world watching, can we begin to explain how we got here. From the moment 3I Atlas was first detected, it was clear this object was different. NASA's early tracking data, confirmed by ESA and independent researchers at Harvard and Caltech, showed a trajectory that did not originate within our solar system. This alone placed it in a rare category, an interstellar visitor, only the third of its kind ever observed. Initial spectroscopic analysis using the James Webb Space Telescope suggested a familiar composition: ices rich in carbon monoxide, traces of water vapor, and organic compounds consistent with long-period comets. At least, that's what we thought. The object was first spotted by the Atlas Survey telescope in Hawaii, then rapidly picked up by follow-up instruments in South Africa and Australia. Within 48 hours, Hubble was tasked with high-resolution imaging, while JWST began infrared analysis from its vantage point at Lagrange Point 2, 1.5 million kilometers from Earth. The global nature of the observation was unprecedented. Radio telescopes in Chile, optical arrays in the Canary Islands, and space-based sensors all focused on a single point of light moving silently through the dark. Everything, at first, made sense. But science is often most dangerous when it feels comfortable. 48 hours before today's event, 3I Atlas was behaving exactly as predicted. It was traveling at approximately 42 kilometers per second relative to the Sun on a hyperbolic trajectory that would carry it past the inner solar system and back into interstellar space. Its coma, a faint cloud of gas and dust, was symmetric. Its light curve showed regular fluctuations consistent with a slow, tumbling rotation. Thermal models placed its surface temperature near 180 Kelvin as it approached perihelion. Then, 11 hours later, something subtle changed. The first anomaly was so small it was nearly dismissed as noise. A fractional deviation in acceleration, just 0.03 millimeters per second squared, appeared in data from ESA's tracking network. At first, analysts attributed it to outgassing, a common phenomenon in comets as solar heating causes jets of material to erupt from the surface. But when the same deviation appeared in NASA's independent models and again in data from a private observatory in Japan, concern began to grow. This was not random outgassing. The acceleration was smooth, continuous, and most troubling of all, it was directional, not aligned with the Sun, but with the object's velocity vector. No natural process could produce such symmetry. 6 hours later, spectroscopic readings revealed a second anomaly. The emission lines associated with cyanogen and diatomic carbon, normally prominent in cometary spectra, began to fade. In their place, a broad, featureless reflection spectrum emerged, more consistent with a metallic or crystalline surface than with porous ice. At the same time, visible light imaging showed a subtle but undeniable change in shape. What had once appeared elongated and irregular now looked compact, controlled. At 19 hours before today's event, radio telescopes detected a brief electromagnetic pulse originating the vicinity of 3I Atlas. It lasted just 0.8 seconds and spanned frequencies from 1.2 to 1.8 gigahertz. No modulation, no repeating pattern, just a clean, isolated spike. Then, silence. By that point, the story had moved beyond routine observation. Internal alerts circulated within NASA and ESA. Simulation teams at Caltech began running emergency gravitational models, while Harvard researchers reprocessed archival data, searching for missed clues. I remember staring at the data feed as it refreshed over and over, each update making the situation less comprehensible. 11 hours later, everything changed. At exactly 01:54 a.m. UTC, 3I Atlas underwent a sudden, coordinated shift in velocity. Its speed decreased by 12% in under 3 minutes, without any visible ejection of mass, without a flare, without an explosion. The object simply slowed down. In deep space, where there is nothing to push against. According to Newtonian physics, such a maneuver would require an impulse equivalent to releasing energy on the order of 10 to the 14th joules. Yet thermal sensors registered no corresponding heat signature. Infrared instruments saw no plume. There was no debris field, no fragmentation, no shockwave. The object remained intact. Moments later, its trajectory adjusted again, this time by precisely 0.017 degrees, placing it on a path that brought it closer to the ecliptic plane of the solar system. The adjustment was so precise that one engineer reportedly whispered, "That looks intentional." This was no longer a comet behaving strangely. This was an object responding to its environment. Within hours, a full scientific investigation was underway. Dr. Elena Markovich at ESA's Space Situational Awareness Program led a joint task force with NASA's Jet Propulsion Laboratory. Gravitational modeling ruled out interactions with known bodies. There were no planets, no asteroids, no dense dust clouds close enough to account for the changes. Solar radiation pressure was calculated and dismissed. It was 2 orders of magnitude too weak. Spectroscopy teams turned to higher resolution data, analyzing reflected sunlight across dozens of spectral bands. What they found was disturbing. The surface reflectivity of 3I Atlas was not uniform. It exhibited repeating geometric patterns, subtle but statistically significant, suggesting layered structures beneath the surface, structures that were too regular to be natural. At the same time, computational analysis of the earlier radio pulse revealed something new. When the signal was stretched in time and reanalyzed, faint substructures emerged, intervals that corresponded to prime numbers: 2, 3, 5, 7. This was no longer random. It was responding. The scientific community split almost instantly. One camp, led by Dr. Raymond Hu at Caltech, argued for an exotic but natural explanation. Perhaps 3I Atlas was a fragment of a disrupted exoplanetary core, its dense metallic interior exposed by tidal forces during a close stellar encounter. The observed acceleration, he suggested, could be due to anisotropic thermal emission, an extreme version of the Yarkovsky effect. Unlikely, but not impossible. The other camp was less convinced. Dr. Lila Moreau at Harvard pointed to the energy budget. "You cannot get this level of control without feedback," she said in a closed briefing. "Feedback implies sensing. Sensing implies structure, and structure implies design, whether biological, technological, or something else entirely." Agencies hesitated to use certain words. Internal memos leaked, then vanished. Simulations grew more complex, more desperate. And then, just as consensus seemed within reach, a second wave of anomalies struck. At 07:12 a.m. UTC, one of the faint secondary fragments detected earlier, initially thought to be a cloud of dust, disappeared from all sensors simultaneously. Optical, infrared, radio. Gone, not drifting away, not fading, simply absent. Minutes later, magnetometers aboard several Earth-orbiting satellites registered a spike of 4 nanoteslas, small but global. In the same hour, shortwave radio operators reported brief blackouts across the Pacific. Navigation satellites experienced transient timing errors measured in microseconds. Even migratory bird tracking data showed unexplained deviations. Individually, these events meant little. Together, they painted a picture that no one was ready to see. Control rooms fell silent. Encrypted channels lit up. Governments requested briefings they would never publicly acknowledge. And through it all, 3I Atlas continued its silent passage, now rotating more slowly, its light curve unnervingly smooth. I remember the moment someone asked the question no one wanted to ask. What if it isn't passing through? What if it's stopping? In the calm that followed, as data stabilized and models struggled to keep up, the tone shifted. Less alarm, more reflection. Maybe we're not witnessing the end, but an invitation, a test, a mirror held up to our assumptions about the universe and our place within it. For centuries, we believed intelligence was rare, fragile, confined to warm planets around stable stars. But the cosmos is vast, and we have explored only a fraction of it. Perhaps intelligence takes forms we never imagined. Perhaps it travels not in ships, but as objects, observers, messengers. Or perhaps we are still clinging to patterns where none exist. As of this moment, 3I Atlas remains under continuous observation. Its next maneuver, if there is one, cannot be predicted. Its origin remains unknown. Its purpose, if it has one, is a mystery. One final detail logged just minutes ago stands out. The object's rotation axis has aligned within 0.5 degrees of Earth's orbital plane. Coincidence, say some. A wake-up call, say others. The story isn't over. In fact, it may only be beginning. Subscribe to follow the next update, because whatever 3I Atlas does next, whatever it is, it will force us to rethink not just what's out there, but who we are. And the most unsettling question of all remains unanswered. What happens when it decides to move again?